All right. What we're going to do today to start is we're going to practice our SQL intensely. All right. So we'll go over a bunch of examples of it to try to reinforce all the concepts that we've talked about in the past few times. Now I'm going to define a database, and I'm going to throw some questions at you, kind of in random order. In other words, I won't say if it requires a group by or not requires a group by. I'll just make them up off the top of my head and take a minute to think about each one, and then we'll go over it. And we'll see how that goes. All right, and then based on that, we'll decide how to proceed. All right. To start off, let me define the database that we want to do. We want to do a database that keeps track of the alumni of a college. Okay? So, we have an alumni table. All right. And we have their alumni ID, which is the primary key to this table. And we have their first name, last name, city and state, and major ID. Major ID being a foreign key into a major table. Now, for simplification, we're going to say that each person only has one major. I know some people graduate with 2 degrees or whatever, but we'll say for simplification, they only have one major. All right? We then have a list of funds that alumni can donate to. And there'll be a fund ID, the fund name, and the goal of how much money that fund wants to raise. You know, it might be that we have a scholarship fund and we want to raise $10,000 for it. We have a building fund and we want to raise $400,000 in it, or whatever. All right? We then have a donation table. And that will have a donation ID as a primary key. It will have the alumni ID of the person that made the donation. It will have the fund ID of the fund that the donation was for. And then it will have an amount and the date that it was donated. All right, that's, I think, a reasonable database. Again, a more realistic database might allow for multiple majors and probably would have a starting and ending date of the fund, you know, that this is a scholarship fund for 2010 or whatever. But I think that's good enough for our purposes. So what we're going to do is we're going to run through a series of SQL statements. I'm going to describe them to you. And you can write down the SQL statement for it. Take a stab, and then we'll go over it. One more thing in the alumni table is the year that they graduated. So, you know, the class of 2009, for example. All right. First SQL statement I want to see is I want to see the first name and last name and description of the major for everyone that graduated in 2010. I want to be sorted by major, then last name, then first name. So let me write this down. I want to see the first name and last name and description of major for all 2010 graduates. Okay, so take a second, think about it, and we'll try to work our way through it. One thing I didn't put is I didn't put the sorted by the description of the major, last name, and first name. Okay, let's take a shot at this. Someone care to begin? Select. All right, we got that much. What's next?
First name, last name, description, and year.
Okay, first name, last name, description, and year. Okay. What's after that?
From alumni, major.
From alumni, major. All right. Where? Or alumni major ID equals major ID, and year equals 2010. All right, good job. If I wanted to split hairs, I would say I didn't necessarily want to see the year for those people. It doesn't hurt to put the year on there. I said all I wanted to see was the first name, last name, and description. So you, strictly speaking, you don't need the year up here to use it in the where clause. So I just wanted to illustrate that. So actually you gave me an extra field, and that's fine. But you didn't have to include year up there, because you can use it in the where clause even if it's not included in the list of columns to select. All right, so that's not a problem. All right, let's try this one. Give me for every fund, give me the fund ID, fund name, and the total donations. So I want to see for each fund the ID of the fund, the name of the fund, and the total of the donations. That is the total amount. That's what I mean by total donations. For those of you coming in late, this concludes the answers to the final exam that will be given at the end of the year. No, I'm just kidding. We're just going and we're writing SQL statements from this database. And those are the 4 tables in the database. And for this particular example, we want to see the fund name, the fund ID, the fund name, and the total value of all the donations that have been made for that fund. So we're taking a second to think about it, and then we're gonna discuss that one. For those of you at home, next time I'll be sure to bring the Jeopardy music to keep you entertained while this question is up. All right, let's take a shot. What do we want to see? We want to see the fund ID, fund name, and the total of all the donations for that fund. So, how do we start off? Uh-oh. We're going downhill. All right, select. Select what? Fund ID? Fund name? And sum amount? Okay. It's not a bad start. That part of it is correct. All right. What's next? The next is going to be the from clause, right? And the from clause, what tables are we pulling those things from? We're pulling the fund ID and fund name from the fund table, right? So we'll say from fund. And we're pulling the amount from the donation table. So the from will be from fund, donation. All right. What's next? Yeah, right. Where? Exactly. Where fund.fundID equals donation.fundID. All right. We know we have more than one table, so we know we have to match them up somehow. And you're going to match them up via the primary key of one to the foreign key of the other. All right. And what's the last part of this? Group by. And what do we put in the group by?
Fund ID.
Mm-hmm.
Fund name.
All right. Very good. You guys are working great together as a team today. All right. Again, in thinking this through, all right, if you weren't sure how to proceed, you know that I said I wanted to see not every donation, but I wanted to see the sum of the totals. I wanted to see, or the sum of the amounts, the total of the amounts. Therefore, you know that aggregate functions are involved. All right. And I also said I wanted to see the fund ID, the fund name, and the total. All right? So, we know we want select. We want to see the fund ID because I said we wanted to see it. The fund name, we want to see that. The aggregate function for the total of something is the sum function. So sum, and what do we want the sum of? We want the sum of the amount. All right? So, this part, that's the stuff that we want outputted. Fund ID, fund name, sum amount. All right. What tables do those come from? Well, those come from the fund and the donation table. We're using more than one table, so we have to match them up. Right? So we say where, how do we match them up? By matching up the keys. So where fund ID equals donation fund ID. And then finally, we want it, what on the select line is not an aggregate function? Fund ID and fund name. So therefore, those need to be in the group by clause. Now, we made one tiny mistake. And shame on me for not catching it. Does anyone see the one tiny mistake we made? We would have to say fund.fundID. All right? Because remember, there's a fund ID both in the donation table and in the fund table. So originally we just had select fund ID. That wouldn't go. We have to say fund.fundID. Fund name, we can just say fund name because there's only one column in those tables that have fund name. All right? All right, here's kind of a fun one. I guess that largely depends on your definition of fun. All right. Let's say someone at the alumni office was thinking about, I remember this tall guy that was in my classes years ago. All right. And what's his name? I don't remember. His name is something like Zeldman or Zellers or Zelnick. I know his name starts with a Z-E-L. The last name starts with a Z-E-L. All right? And I don't know what year he graduated, but he graduated sometime in the 80s. Okay? And I do know that he was a computer science major. All right. What could be a query to help this person find out the full name, first name, last name, city, and state for someone whose last name starts with Z-E-L that graduated sometime in the 80s. Let me change that. I had graduated in 80. Graduated in the 80s. And finally, I know their major is computer science. Let's think about that one for a minute. You get extra credit if you can name the person in the room that fits this description. Oh, sure. Okay, let's take a shot at this one. So, I'll give you this, because it's getting late. You might be lagging a little bit. Select. What do we want to see? F name, L name, city and state. All right. From alumni. Is that it? On the from, well, is that it on the from clause? Yeah, that's a good question. Part of the reason for this one was to illustrate that. The question is do I need to include, if I'm going to reference a table in the where clause, do I need to include it in the from? And the answer is yes. All right? So it doesn't matter where in the SQL statement you refer to that table. If you refer to a table anywhere in the SQL statement, you need to put it in the from clause. All right? So even though there's nothing in here from the major table, because we're going to use the major down here in the where clause, we need to include the major table. Okay. Now, where? We're alumni, major, ID equals major ID. All right. and description equal computer science. And last name, like, quote ZEL. Standard SQL is a percentage sign. In Access, it would be an asterisk. So I'll put the Access one on top, Standard SQL on the bottom. All right. Pretty good job on that one. What you have to do with these, again, is remember all the different clauses and what you're using them for. The select part of it is the columns that we want to display. The from clause are the tables that we want to use. The where clause is really used for two purposes. One, to join tables together. So if you have more than one table, it's going to be included in the where clause to join it together. And the other is to filter it out. So for example, what do we know about this person? We know that they had a degree in computer science and their last name is like ZEL. We did miss a piece though. I just realized that now.
And you're like 198.
That is a good thought. It depends if date was stored as a number or as a string. All right. If the date was stored as a string, then you could say this. You could say year like 198%. All right? But I would assume the year will be stored as a number. So you can't use the wildcard with a number. Wildcards don't work that way. So, how do we put the date in there, or the year in there? Pardon me? Okay. We're running out of space here. Let's put the year on its own sheet of paper. And we have this as a possibility. This is only if the date is stored as a text field. So probably not. Year in, and then what would we do? 1980, 1981, 1982, 1983, 1984, 1985, 1986, 1987, 1988, 1989. Would that work? Yeah, it would work. Is there a quicker way to do it? Because my hand's getting tired. What would be a quicker way to do it? So this would work if the date was stored as a year. But if the year was stored as a number. This would work again, assuming that the year is stored as a number. This would be fine. What's another way that we could do it?
Year is greater than or equal to 19.
Yeah. We could say and year greater than or equal to 1980.
And less than
and
289.
yeah, year less than or equal to 1989. We do have to put the year in there again. In other words, the way you stated it, I'm not sure what you intended, but you said year greater than or equal to 1980 and less than or equal to 1989. You'd have to explicitly say and year less than or equal to 1989. Is there another way to do it? If year between 1980 and 1989. Is there another way to do it? Yeah, there actually is probably one more way to do it. But it would be like this. And then in parentheses, have a bunch of ors. Year equal to 1980 or year equal to 1981, or so on down the line. Probably the two best ways to do it would be this way or that way. All right, either use the between or use that, which is the equivalent of the between. The other two ways would work, and even this way, if it was in an alphanumeric field, that would work as well. All right. Okay, the next one. I want to see the total donations. Well, no, let's put it this way. I want to see the total donations and the average donation by major. Let's see which majors are the most generous. All right? So I want to see accounting has donated $15,000, and the average donation is $70. Business administration donated $75,000, and their average donation is $120. So I want to see the total donation and the average donation broken down by major. All right, let's take a shot at this. I want to see total donation and average donation broken down by major. All right, what do we have for that? Select, description, sum amount, average amount, from, major, donation, and alumni. All right, go ahead. Where? Major.major ID equals alumni.major ID and donation alumni ID equals alumni.alumni ID group by the name of the major. The column name for that is description. Right. All right. Question. Why do we need the alumni table in this? We're neither using it in the group by and we're not using it in the select. Why do we need the alumni table in here? We do, by the way. This is correct. All right, so I'm not questioning that, but why do we need the alumni table in here?
You know the alumni, you know the major.
Right. You need the alumni table in there to connect the donation to the major. Right? If we look, there's nothing directly between major and donation. So there's no way that we can tie the major directly to the donation. The only way that we can tie the donation and the major is, for the donation, we know the alumni. For the alumni, we know the major. And so, that's kind of like a stepping point. And you'll see that in tables. As you're writing the SQL statements, you may want to pull together something from this table and this table. And the only way to get there is through those other tables. Well, you got to go through them then. You got to go and connect them all in a chain. So even if you're not going to use anything from those tables, even if you don't want to see anything in your query, or even if you don't want to use it elsewhere, just to connect those two tables together, you might have to do that. All right. Last one, and then we'll get into some other topics, some maybe more advanced SQL topics. I want to see how many donations are over $1,000 broken down by the year of the graduate, the year of the alumni. So I might want to see that, 1980 graduates had 5 donations over 1,000. 1981 had 8 donations. 1982 had 12 donations, and so on down the line. So I want to count the number of donations, but I only want to count those donations that are over $1,000. Okay, let's take a shot at this. How many donations are over $1,000 broken down by the year of the donor? All right. Select. Year. Sum. Count. Count. Star. Yeah. All right. From. Donation. Do we need the alumni too? If by year, again, by year we mean year of the alumni, not the year of the donation. So we want donation and alumni, where alumni ID equals donation alumni ID. Okay. And amount greater than 1,000. Group by year. All right, good job. All right. Good job on those. What we're going to do now is we're going to consider some I guess additional features in SQL. I guess we could call them advanced features if you want. But they're meant to handle some things that we couldn't otherwise handle. And let's use the same set of tables since they've worked for us this far. Let's see if we wanted to, let's say we wanted to see the first name and last name of everyone that donated more than $1,000. So we want to see the first name and last name of everyone that donated more than $1,000. A single donation of more than $1,000, not an accumulated, but made a single donation of more than $1,000. It would look something like this. Select, let's say, F name, L name, city, state, from alumni, donation, where alumni ID equals donation dot alumni ID and amount greater than 1,000. And for good measure, we'll tack an order by clause on here to order it by last name and first name. That will give us a list of everyone that donated, that made a single donation of more than $1,000. All right? I hesitate to say what's wrong with this SQL statement, but what's wrong with the SQL statement? What might be an unusual condition that we might see? Yeah, if they made a couple of donations of more than 1,000, we would see their name showing up twice. If they made 5 donations, would show their name 5 times, and so on. And, well, that's probably not a good idea, right? Let's say we only wanted to see a person's name once. We just want to see the list of people who've donated more than $1,000. We can do that by tacking on the distinct clause at the beginning of the select. So if I say select distinct F name, L name, city, state, it will only show that combination of F name, L name, city, and state one time. Now if we're going to do that, we probably should add alumni ID on here too. Because there could be 2 John Smiths in New York City. And if there's 2 John Smiths in New York City, we would want to show each of them. All right? So we'd want to include their alumni ID. That would guarantee would show each of them. All right? So the distinct will only show this combination of values one time. So that's a way of eliminating duplicates. All right. So that's one sort of advanced thing that we could do. All right. Now we saw in this one how we could use an aggregate function, and we could get donations over $1,000. What if I wanted to see the total donations to a fund? What if I only wanted to see the funds where the total amount donated was more than, say, $10,000? All right? I don't want to see individual donations being more than $10,000. I want to see those funds where the total amount donated is more than $10,000. The where clause isn't going to cut it for that, right? We can't use the where clause then, because we don't know how to filter out individual donations. All right? In other words, $10,000 could be gotten by 10,000 people donating $1, or 10 people donate. It's late in the day. I'm trying to do the math in my head. Or 10 people donating $1,000, or one person donating $10,000. Right? So we don't know how to filter out individual donations. We want to filter out based on the total, the sum. And there's a separate clause for that that's called the halving clause. The halving clause works on aggregate functions, sort of like the where clause works on individual rows. So let me write the statement using the halving clause, and then we can talk about it. Select fund ID, fund name, some amount from fund donation where fund ID equals donation fund ID, group by fund.fund ID and fund name. Now if we did this, this would show every fund and the total amount donation that had been donated, the total amount of the donations. If we want to only show those funds where the total donations are more than that, we can't put a where clause to say where sum of amount equals or is greater than 10,000, because the where clause works on individual rows. What works on groups of rows is the halving. So I could say halving sum of amount greater than 10,000. And what it would do, what SQL would do, is it would go out, calculate for each fund the sum of all the donations, but then it would only show me those funds where the sum of the donations was greater than $10,000. So that's why I say the halving is sort of like the where clause. It filters stuff out, but the where clause filters out individual rows. The halving clause filters out groups of rows. So you'd use the halving if you ever wanted to see the total greater than a certain amount. If I wanted to select classes where the enrollment was, the count of the students was more than 50, I would have to use a halving clause, right? Because I would sum up or count the number of students that are in a class, and then I'd blah, 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 halving count star greater than 50. All right? There's a couple more sort of oddball or advanced topics that we'll talk about next time. And we'll also spend a little bit of time talking about the statements that actually update the tables. Insert, update, and delete. All right? And maybe a few other things as well. All right? Good job on the practice. Really, You know, that's really the only way you're going to do this is just practice it over and over. All right, we'll see you over in lab.